All right, continuing our annuities lesson. In yesterday's lesson, we learned a formula for A equals, and in this one we are learning an equation that P equals. So these are planning for a future with an annuity. So this is something you'll think about: how much money do I want in the future, and work backwards to find out how much we should be putting in each month or each quarter. So this will help us to find the payments that are needed to achieve a financial goal. So it's a similar formula to yesterday, but it's just rearranged and solved for P. So you just have to pay attention to which formula you're using. How much do you need to deposit monthly for 30 years to achieve a goal of $1 million in the retirement annuity plan with an annual interest rate of 6% compounded monthly? So that A is $1 million. That's our future goal. R is 6%, 0.06. N is 12 because we are compounding monthly and we are depositing monthly. And T is 30 because we're using 30 years. So here's our formula. Again, the formula is going to have parentheses in the denominator for our variables. And substitute in all your values. Again, please practice this on whatever calculator you plan on using for the mini quiz, as that's the biggest mistake: students punch it in wrong. So we have $1 million, parentheses, 0.06 divided by 12. Close your parentheses. Then we put a division bar for the big fraction bar. In the bottom, we need 2 open parentheses. Close them once. We need our exponent, our carets, 12 times 30. Close that. Make sure you arrow over to get out of your exponent and then put your -1. Close your parentheses. We should get a smaller number because this is a amount that we're going to be depositing every single month for 30 years. So $995.51 per month. And then our formula is the same as it was yesterday for interest. We're going to take our A value, which in this case was given to us, minus the total amount deposited, which is P times N times T. So our A value is $1 million. That was given to me. My P value is what I just found. N is 12, T is 30. Multiply those values together and we'll get 358,383.60. And last but not least, subtract. So you are making $641,616.40 in interest just by depositing that every month. Now this is kind of high to be able to deposit every month. So this person must have been making a lot of money to be able to save that much. But as you can see, that allowed them to be having $1 million when they retire. Example 2, you would like to have $20,000 to use for a down payment. So you would like to have in the future, that's A. 5 years, interest rate of 8%, depositing monthly. So again, we'll punch those into our formula. A times R divided by N, all over 1 plus R divided by N to the NT power, minus 1. When we punch that in our calculator correctly, we should get $272.19. Again, if you're struggling with the calculator, you may want to type the top part in, get an answer. The bottom part in, get an answer, write them down, and don't round them, and then divide them too. So, how many of the $20,000 down payment comes from deposits, and how much comes from interest? So remember, to calculate our interest, we take A minus P times N times T. Now, the P times N times T is the deposit part. So we're going to be taking the P, which we just found, 272.19, times 12 times 5. So that means that our amount from deposits is $16,331.4. And then we subtract that, we find that the interest is $3,000. So notice the interest is a lot less than the deposits, and that's because we were only doing this over a 5-year span. The more time that you let an annuity take on, the higher interest you will accrue. Part C and D is just continuing that same question from the top. Assuming everything stays the same except we are compounding and depositing quarterly, how many times a year would quarterly be? 4. So A, R, and T stay the same, but N changes to 4. And part D, assuming all the same except compounding and depositing annually. Annually means that you're compounding how often? Just once, 1 time a year. So in this case, N would be 1. So the formula from the last one's going to stay exactly the same except for the N value. So remember our shortcut on the calculator for that part C, we should get $823.13. But for my part D, so I don't have to retype that all in, remember you can just press second, enter, and then you can go back and change anything that you need to. So the only thing that should be changing here are the 4s becoming 1s. That's our N value. You should get 3,409.13. And our closer just says, compare your answers from example 2. What do you notice? What conclusions can you draw about the amount of times you deposit/compound money? So what we should notice is that the more times we compound, the less money we put in each time. Looking back, if we compound and put in 12 times per year, we only had to put in $272. But if we put in only 4 times a year, it got higher, and only 1 time a year, it got even higher. So the less times you compound or deposit, the more money you'll need to put in each time. So they kind of have almost an inverse relationship there. You are now to complete the 8.4 homework assignment as well as the 8.4 mini quiz.